All right. The principle of redundancy is used when the system's reliability is improved through redundant or backup components. Assume that a student's alarm clock has an 8.2% daily failure rate. Complete parts A through D. Okay, what is it telling us here? That the probability of this clock failing, so the probability of a failure is 0.082. That's what it told me right there. It says, what is the probability that a student's alarm clock will not work on the morning of an important exam? That's only that one answer, 0.082. Just got that one clock. He's got that much of a probability that it won't work. If the student has two such alarm clocks, what is the probability that they both fail? So we want the probability of two failures. Okay, what would the probability of two failures be? All right. So if that's the probability of one right there, we could say equals sum of that number, and this time we could square it because we're going to multiply them together. So now it says 5 decimal places, so that's 0.00672. Now let's click it. 0.00672. 5. Okay. Then it says, what is the probability of not being awakened if a student uses 3? Okay, well, it's basically the same thing again. The probability of 3 failures, what is that going to be? Equals sum, the probability of the first one, and then we would raise that to the third power. And 5 decimal places, what do we get? 0.123055. Okay, do the second and third alarm clocks result in a greatly improved reliability? Well, you've got a little over an 8. Here you've got about 1%. And with 3, you've got just a very small fractional percent. So yes, because you can always be certain that at least one will work. No, there's always the possibility that they could all fail. Yes, because the total malfunction would not be impossible, but it would be unlikely. That is your best answer.